Hmm? Mm-hmm. Are you? You gonna come out and play?
Thursday night to just look all these over again.
I'm working on my notebook Thursday.
All right, so,
Actually do for 24 hours. So weird.
Yeah, we do.
I mean, we do, but I'm done.
if we have a setup kind of like this thing that I was showing the other classes, remember how I showed you,
Is your photo on
okay, find your major, it's accidental that it happened to fall on that. But this is, that's your major. That's your minor, more or less. I mean, in terms of it's your minor angle. So that's real. I really, you guys, more and more, the more, for the time being, at least, unless I find a really elegant way of showing you guys, this is the important stuff, because that's the symmetry. If you get the symmetry, you're good. If you know where the major and minor and how they're oriented, you're well on your way. Now, in terms of the bounding box, though, this is the thing I figured out I was doing yesterday. So if I have that bounding box, what I realized I was doing yesterday, and I'm gonna show you one other method to refine your ellipses. What I realized is, do you see that you have 4 unequal quadrants? But do you see that this one's the smallest one? What I realized I was doing was I was unconsciously always choosing the smallest quadrant to draw like if I could draw this, basically, like, if I could go from here to here, and maybe I hit like right up here somewhere. You're gonna hit once per quadrant, but not necessarily where the axes are. So if I go like that, and I can draw that quadrant, and I know I need to be crossing here at a 90, and I need to be crossing there at a 90. Do you see that this, because we know that the ellipses have symmetrical quadrants, that once I draw the one quadrant, I can map it into the others? But if I draw this one here, well, that one's not gonna fit in these other 3. This one here isn't gonna fit in these other 3. This one here isn't gonna fit in one of the other 3. You see what I mean? So this nearest smallest quadrant gives me a pretty good guess. If I draw it almost as large as I can in here, it's gonna still fit in the other 3. Does that make sense to you guys? Yeah.
And doesn't necessarily have to touch all of the sides.
No, well, theoretically, your ellipse should touch the bounding box in each quadrant once, in one spot, theoretically. If you drew it perfectly, yeah.
So, with this being at like an extreme like right angle to where the light would be like somewhere like that, how would, I know, I'm still kind of questioning the whole like termination point thing where like mine is kind of off to the side, but this one's kind of like pointed like on it, like, so how would you find like the highlight spot and like what?
On the Terminator?
For, yeah.
Okay, we'll get to that in just a second. Let me do one more thing on the cache setup.
I had a low light source, so it was below the top of the stair. And my bound box was huge, but then
Yes.
my quadrant was tiny enough. It seemed illogical to me, so I
Huh.
drew a really small ellipse because the smallest quadrant was so small, but the other quadrants were huge, so.
You know, can I see your drawing for a second?
um,
Because there might be something I can show you on that. And it's not, you guys, well, I'll hold that up. Actually, does anyone have a tracing paper pad I can borrow for, like, can I borrow your marker pad there for just a minute? If I want to see the drawing, I can just go ahead and get it. Well, so this is actually, the reason I wanted to play with this a little bit, you guys, this is exactly the kind of day that I wanted today to be, in terms of you guys having some of these weird problems, because I think, this next thing I'm gonna do is, I think, one of the biggest issues. And even if you don't get the rest of the ellipse correct, if you get this part of it correct, it'll look pretty good, all right? What I want you to keep in mind is this major axis. If you have that going well, you'll be in pretty good shape. And then if you could find the center point, which is right there, and draw a perpendicular. Okay, I think I see what's going on. Let me ask you a question, Katrina. What's this point here?
It's where the radiation line, the bottom, it runs through the touch point on the drill.
Okay, this is, so, you guys, this is the shadow of a touch point, all right? But this is the problem with this, and this actually is exactly, I'm gonna show you one other method to try to make these things more accurate. But I actually did the exact same thing last night to see if it would, if that would help, and I found a flaw in it, and here's the flaw. Remember when we did the diagram with the top of the hemisphere not falling on the outside of the circumference, how it falls a little bit inside? What you need to find when you're casting the shadow of one of these things, actually visualize it this way. That's the top of the sphere, of the hemisphere. Now let's say I put a light on it, and you find the shadow of this point, that's not in shadow actually. What you need to find is not the shadow of this point, you need to find the shadow of this point that's on the outside of the circle, where the terminator is. And it's actually it's back here somewhere. Yes.
So it's like you were finding the shadows from the Terminator of Delilah, like you would like.
Right. Now, let me show you guys the method that I'm gonna show you so that you can, so what I'm saying is this point probably should be about here. And that will round off your ellipse too. So what I'm gonna suggest you guys do is this. Thank you. Be sure to get this later. So what I'm gonna suggest you guys do is this. The way that I had you guys draw this, it has a couple advantages. If we assume that this is the line of vision, we can find two additional points on your ellipse. Okay, everybody watch this, because this is about the best help I can give you for making these symmetrical additional points. Watch. There's 2 points I can trust. Here's what I'm trying to find. Let's say I draw the terminator. Wait, let me do it accurately, more accurately.
This is
So let's say I draw an ellipse like that for the terminator. There's two other points that I can know. What I need to find is I need to find where this, okay, let me see if I can explain this. You guys see that if I do something like this, there. If I do something like this point right here, this point right here on the terminator is the shadow, right, is connected to that point. You with me? But you see that this point is inside of the drip line. Visualize the drip line for this sphere. The drip line for the sphere is out here. So this is inside of that. You follow me?
Oh, so it has to be inside the trip ellipse because it's inside, on the opposite side of the.
Yeah, I'll show you in a second. But here's 2 points that we can depend upon. I can depend upon